We have a 1.5 volt dry cell. Over time, the light intensity produced by the torch decreases, the cell goes flat. We're trying to measure the EMF of the cell. So we have, the student has connected a voltmeter across the bulb that is connected to the cell. And the question is, why will this voltmeter reading not be the EMF? It won't be the EMF because there is internal resistance in the circuit. So that would mean that voltage is dropped across that internal resistance, and therefore not all of the EMF will be dropped across the bulb. So whatever our EMF is, we will have our terminal PD, which is the voltage across the terminals of the cell, or the external components, same thing. And we will have a voltage across the internal resistance, which I'll call V int. And how it would work is the voltage that we pick up, so that will be the terminal voltage, that will be equal to the EMF minus the lost volts, which is the voltage across the internal resistance. Part B. So student B correctly determined the EMF of the unused cell as 1.63 volts. So an unused cell, so epsilon nu, is equal to 1.63. That's the EMF. And its internal resistance is told to be 1.15. He then repeats the experiment for a cell that's been used for a few weeks. When he connects a voltmeter across the used cell, the reading is 1.36 volts. So that's the new EMF. Whenever you have a cell which has or doesn't have internal resistance, and if you're just to connect a voltmeter to that cell and nothing else, this voltmeter will read the EMF of the cell. And the reason for that is because the resistance of the voltmeter is very high, and if the resistance here is much higher than the internal resistance, then pretty much all of the voltage will drop across the voltmeter, and therefore it would measure approximately the EMF of the cell. The higher the resistance of the voltmeter, the more accurately it would measure the EMF of the cell. So our new EMF, so I'm going to call that epsilon U for the used cell, that's equal to 1.36 volts. The EMF has decreased. It then says a bulb of resistance this is connected across the used cell and the reading fell to 0.84. So let's change this circuit. I'm going to change this. That's now our bulb. And then we have our voltmeter, which is connected across the cell. Connecting a voltmeter across the cell is the same as connecting it across the bulb. You measure the exact same voltage. And then we're told that the reading on the voltmeter is 0.84 volts. The 0.84 volts would be the terminal voltage, so that's capital V. So that's the voltage across the terminals of the cell or across the external load. And we know the external resistance is 5.92. Okay, so what's the question actually asking us? So student A suggests that the cell goes flat as it is used because the EMF decreases. Well, we've already identified that that is true. That is the case, so student A is correct. We're trying to determine whether each student is correct in how the cell goes flat. And then student B suggested it's because the internal resistance increases. We're not told the internal resistance, so we need to work that out. So that's going to be the next thing that we do. So if we think about some of the equations that we have, we could use EMF is equal to terminal PD plus IR, and then work out what our internal resistance would be from that by rearranging that equation. But to do that, we'd have to work out current. And we can work out current from the terminal PD and the external resistance, because the 0.84 volts is the voltage across the external load. So the current will then be equal to 0.84 volts. So I'm just using V is equal to IR. 0.84 volts divided by the 5.92 ohms. And that gives us a value of 0.1419. So that is the current that's being drawn from the cell. and is going through the bulb. Okay, so we have our current. Now we can put everything into this equation. So the EMF that we have here is the EMF of the used cell. Resistance is EMF of used cell minus V, all divided by I. So that would be 1.36 minus 0.84, all divided by I. That gives us 3.66 ohms. And the old internal resistance was 1.15, so that's the new cell's internal resistance. And for the used cell, it's 3.66. So the internal resistance has increased, so student B is also correct. So both student A and student B are correct.